Alright, in this video, we are going to tackle the log class.
And I guess its name pretty much suggests what it is.
Right, basically, throughout the systems we create in the drum game, it would be very helpful if we would give ourselves some text debugging ability.
Now, debugging is going to be a crucial word in this case because this is not the kind of log that you would always want to have available to a player.
Exactly. There's some of the elements of this log are actually going to be fairly data heavy, and so that means you want to use this primarily just for monitoring what's going on in the game.
Right. This is not going to be like a lot of games you might have played on your PC where you can hit the tilde key and bring down a console. It'll function the same way, but you don't want to leave it there in the final version.
Exactly. Some of the elements could be used in such a system. It's just there's further optimizations you might want to add. Also, a quick description of exactly the presentation here. The idea is, in a console application, it's very easy to write debug information to the screen. You have the very convenient console.writeLine method, and makes a very easy way to get text out to the screen. But here inside of XNA, of course, we can write text easily enough, but it's not formatted in a contained and automatically scrolling manner.
Okay.
So what the log is basically going to do is provide an automatically scrolling container for text.
Okay.
The idea is that we can write lines of text to our log at any point in time, and the log will handle automatically scrolling, so we always see the last few lines of text.
And I don't like to count on too much of anything, but hopefully, if you're this interested in writing games that you're watching this series, you've got enough experience with games that you may have seen logs like this on various PC games.
Exactly.
They're fairly common.
Exactly. So, at this point, we'll go ahead and jump in with the creation of the log class. Alright, going over here to our project, I'm going to pull content back up, collapse that, and we'll go under core. We'll add a new class, and we'll call this log. We'll hit add. Once that drops in...
This is not going under game, this is going under core.
That's correct. Okay. Under the premise that we want this log class to be as standalone as humanly possible. Meaning, if you wanted to, this would make a good class to move game to game, since all of the elements are self-contained within the log itself.
Yeah.
The idea here is that the log can function without any of the other systems.
It's like a generic log.
Exactly.
Whatever you want to put it in.
Alright, we'll pull out our sub namespace, so we're just under the drum game namespace. And the class itself is going to be a static class.
Okay.
And we will need a couple of using statements. So we'll drop in using Microsoft.xna.framework as well as Microsoft.xna.framework.graphics.
All right.
Now, moving into the log class itself,
time for fields.
We need to set up some fields. We're actually going to have both some static fields and some instance fields within, or excuse me, some let me rephrase that. Obviously, it's a static class, so we're not going to have instance fields in a static class.
I was with you.
What I was looking at was public. Some of the methods will be available outside the log, and some of them are for internal use inside the log.
Okay.
Let's begin with the public fields.
Yeah, get those out of the way.
We need to store things like whether or not our log is even enabled, so we know whether or not to draw it. We need to store what the rectangular bounds of our log is going to be, meaning where on screen is it positioned and how big is it. Okay. And we're also going to store a background color and a text color. Now, we'll begin with enabled. This will be, of course, a public static field, and it will be of type Boolean. So we'll have bool enabled.
Wow, that's called the home row.
Yes, indeed. And we'll use a field initializer to set this to true. Yay. So by default, our log will just be enabled. All right, moving on. We need to establish our rectangular bounds. So we'll put in a public static rectangle field called bounds. Moving on from here, we have a background color and a text color. You could almost say background color and foreground color if you wanted to.
I suppose.
And
I like background color and text color.
Well, it makes sense, because the background color is going to be used to draw the bounds. Basically, our log window, if you will, is simply going to be a semi-opaque square.
Okay.
Defined
a lot
by
of logs are that way.
And defined by the rectangular bounds. And, of course, we're going to draw text on top of that that rectangular area. The color of the text will be defined by text color. Okay. So let's drop these in. Public static color. The first is background color. and we'll initialize these to default values. You can see that they're public, so if you want to change these later outside of the log, that is exposed. But if you're just setting up the log for debugging purposes, chances are you just want to see information and you're not too picky about what color that information might be. So the background color is going to be black, but it's going to be semi-transparent. We'll specify a value of 172 for the alpha channel.
Okay.
All right, moving on. We need the text color. That will be a public static color called text color. And we will again use a field initializer to specify a default value. Here we've come up with a color out of the hat specified by the RGB values 160, 180, and 235.
Which is a pale blue?
Yes, it'll be a bluish color. And we'll also make it semi-transparent, though not quite as transparent as the background, 196. Now, of course, these were colors just happen to work well with the colors in the drum game itself.
Absolutely, make it any color you like.
So again, these are, and also they're not set elsewhere in something like a style, because again, this is not really meant for end users to see. This is for you as the developer.
Right, there's no reason why later on your own, if you wanted to expand style to take in what the log's going to look like, it'd be real easy to implement.
Sure, if you did end up exposing this for end user use,
yeah,
it'd be very easy to tie in.
Ooh, so you could go into your config file and change the way the log looked. Fancy, sort of.
All right, moving on, we also have a handful of fields that are private, things that we will need to know inside the log class but don't necessarily need to be exposed otherwise. Now, of course, they will all naturally need to be static. Now, we're going to have a series of fields that are going to describe some of the visual elements. We're going to have a font that will be used to draw the text. We'll have a texture that will be used as the fill for the background. And with those alone, you might be wondering, well, we already have fonts in the style. We already have a specific fill texture in style. So why create additional fields here? And the idea is to make sure that we don't have any internal dependencies where the log is explicitly dependent on the style class.
Okay.
We will, in actuality, be using things from the style class when we create the log, or rather initialize the log. But the idea is to make this code as portable as possible.
All right.
So that way the log can be moved between projects very easily.
It doesn't absolutely have to have that same style system with it.
Right, so it won't be directly dependent on style, because it'll just use its own internal references. Where those come from will be dependent on whoever creates the log itself. So the first of these is a font, or rather a sprite font. And we'll simply call this font. We'll also have a texture. So static texture 2D, we'll call this texture. And that takes care of the visual elements.
Okay.
Now we have the actual data and presentation elements. We now need to get to the heart of exactly what inside of this text container really contains the text data.
What the log is holding, basically.
Exactly. And what we're going to use to facilitate text storage is a simple string list.
Okay.
Because that will give very easy functionality to be able to iterate over the various lines so we can draw any line at will. So we will make a static list of type string, and we'll call this entries. And we'll go ahead and initialize and create a string list. So new string of type list, or excuse me, list of type string.
I'm with you. I was totally with you.
Alrighty, we need two more things to describe how our lines should be drawn. We're going to maintain a value that is going to contain the height of an individual line of text.
Okay.
Now we're going to record this so that every single line is guaranteed to be the same height. Of course, depending on what font is used, you can run into scenarios where text with capital letters could be taller than some text with lowercase letters.
Sure. So if your line height, as long as it's taller than your capital X height, then you should really also be defining the amount of space in between each line.
Exactly. If you make it a little bit taller than your overall, then you'll also be able to specify the space in between lines. Right. But the idea here is that we want to make sure that every line is exactly the same height.
Yeah, that's how much room is going to be given to each line, no matter what font you're using.
And this makes scrolling a little bit more deterministic, easier to predict.
Sure.
And it also makes it possible to calculate how tall, if you were to measure all the lines of text put together, how high that would be on screen.
Okay.
So we'll drop this in as a static integer, and it will be called line height. All right, one last value we need, and that is, of course, the log is going to need to be able to scroll. We always want to be looking at the most up-to-date information added to the log, and so we're going to record a value of how many pixels the log has been scrolled.
Okay.
So basically, as we add lines of text, we'll run a calculation to make sure we're all scrolled to the bottom, but then we need to record what this offset is. So when we actually go to draw lines of text to the screen, we know how much has already scrolled off screen. So this will be a static integer, and we'll simply call this offset.
Okay, and this would kind of like be the difference in size between what's on the screen and what has been written to the log that has yet to be scrolled to.
Exactly. Another way you could look at it is just the scroll offset in pixels.
Okay.
Amount we've scrolled down, but given in pixels instead of lines. All right, one last field we're going to hold, and that is going to allow for file writing functionality. We're going to leverage the stream writer class provided in system.io, and this will give us the ability to put our log into a file writing mode. The idea is that for general use, it's meant to be used as a screen object. You just see the lines of text on screen and that's it. You might run into a scenario where you want to sample the logged information and save it to file for use later.
Sure.
So we're going to provide the functionality to have our log open up a new text file and dump every line written to the log to that text file.
Okay.
So we're going to need a stream writer in order to accomplish this.
Do you need to use System.io first?
Yes, stream writer is held within system.io. You'll notice that stream writer isn't in place yet. So we need to add a using statement for system.io. So now you'll notice stream writer is available.
Cool.
We'll simply call this writer. And we won't worry about creating the stream writer because, of course, when we create it, we need to specify the file that it will be writing to. And that's going to be handled a little bit differently.
Okay.
All right. This takes care of the fields that we'll need. So now we're going to advance into the methods that will be created. And the way we're going to address this is by simply providing a method skeleton first, a bunch of empty methods, so that we take care of any interdependencies. We'll write all the methods and then go back in a second pass and code them all in. So beginning from the top, we will have a method called startFile. So this will be public static void startFile.
Now, what is the purpose of this method?
StartFile is going to begin a file writing session. The idea is that as long as our log is enabled, it's taking in lines of text and showing them on the screen.
Yeah.
But it is not at that point necessarily writing log lines to the hard drive.
Okay.
What startFile is going to do is it can be called arbitrarily at any point in time, and it begins at that point to write any new lines of text to a file.
Okay.
And this will be followed by a method called stopFile.
So it's not going to grab everything that has been logged so far and write it out. It's
That's
just
correct.
Starting at this point, from now on, I want you to start writing out to a file.
Exactly. And then it will be complemented by another method called stopFile.
Which is say, all right, from now on, I want you to quit writing.
So that means in code you could do something like your game launches and no log file is written. Then you need to log the result of a rather lengthy loop. So you invoke startFile and give it a file that you want the loop results to be written to.
Okay.
Then you run your loop, writing things to the log. When you're
stop.
done, just call stopFile and then proceed with your game. So nothing else in the game gets written to the log.
Gotcha.
But you've blocked out that one piece of data or one session to be written out.
Basically, you're applying the functionality to tell your game, hey, log this specific event or series of events.
Precisely. Now we need to pass in the file to use when logging. So we'll pass in a string. We'll call this file name. And we'll just give an empty method body for now. And we can move on to the next method, which is going to be
file.
exactly stop file. So it's public. This also needs to be static, and it will be void, no return, and it will be stop file. And so its purpose is just to see if we happen to be logging at the moment, stop logging and close out the log file.
So what's next?
All right, next up is the initialize method. So once again, public static void initialize. Initialize is going to need to take in a few different pieces of information, beginning with a font. We'll take in a sprite font, which we'll call font. We'll take in a texture 2D, that we'll call texture. And we did not need a comma between the parameter type and the parameter name. We'll take that out. And finally, we will take in a rectangle. We'll call this rectangle bounds. Now, the purpose of initialize is mainly just to get our fields set up. You'll notice that we are storing a font, we're storing a texture, we're storing some rectangular bounds.
Just setting in some initial values to fire up your log. It looks like it's aptly named.
And we are also going to set up the line height, because it's not until we get this font that we know exactly how long or how large our lines of text are going to be.
I gotcha.
We're going to do a little bit of a trick where we can use font.measureString, of course, to figure out the dimensions of any given string. But what we're going to do is measure just 2 characters that should generally represent the largest characters, and use that to figure out what the tallest line would ever be.
Something like capital X and Q or something?
Actually, we're going to use the numeric 0 and Q, so close.
Okay. Oh, close enough.
And then we're also going to make sure that we have scroll. We're actually going to run our scroll to end. The reason is we're going to design our log in such a way that lines could actually be written to the log before initialize is called. And this is useful since we're going to need some graphical information. And things happen before this gets loaded. We have a games constructor that loads before any of this gets considered. Okay. And it would be nice to still be able to use the log even if nothing's been initialized.
All right.
So that means we're going to design it so that the moment initialize is called, it also does a check to say, all right, has any data gotten here yet? If data's gotten there before initialize, we take that into account and get our scroll set correctly.
I gotcha.
All right, moving on from here, we have a method called append. It will also be public static void return append.
Now imagine this is just going to add new lines of text to the log.
Exactly. We're going to take in text as a string, and it is the central method for causing data to be added into our entries list.
So put entry into log. Very simple.
And that is exactly what it's going to do. The reason I say it's central is because generally you will use methods that we're going to write following this one, write line methods, to correspond roughly to the console versions.
Yeah.
But the reason to have append is it's the one central place. Any other method that might be bringing data in can possibly manipulate or otherwise do something to that data, but then it'll hand it off to append. So anything that needs to be done as lines of text go into entries will be done inside of append.
That's what's actually posting the data to the log.
Exactly.
Gotcha.
All right. Moving on from here, we have a method called scroll to end. Let me public static void once again. Scroll to end.
Which is analogous to using the control end key in most writing apps.
Exactly. It'll be a method that will calculate exactly what we need to set our scroll offset to in order to ensure that the last entered line of text is visible at the bottom of the log.
Now, there will be some funny math that we're going to go over when we actually get into coding the functionality of this method, so look forward to that.
But yes, we'll get to that as soon as we begin coding in our methods. All right, immediately following scroll to end, we're going to have a couple of write line methods. So these will again be public static void. The method name will be write line. For the first variant, basically we're going to have 2 overloads to this method. One will simply directly take in a string, and we'll have a second variant which will be used to handle formatting. But let's get these method signatures typed in first.
So this is the easy one.
Exactly. This one just takes in unformatted text and we'll pump it directly into append.
Okay.
Now we're going to have a variant of this. As a matter of fact, to save on time, I'm actually going to copy this whole method and duplicate it. Since this overload is going to have basically everything the same.
Just different arguments.
Yeah, exactly. Different elements will be passed in here. Now what we're going to do here is we need to pass in the necessary information to allow us to run string.format.
Yeah.
Since obviously we don't have a real console in this case, we're not ever going to use console.writeLine. But we want to mimic the console.writeLine functionality where we're allowed to specify a string with various index-based parameters in it, and then specify those actual parameters as additional parameters to the method.
Okay.
So to get a quick example, if we looked at the string type, we have string.format, and the first overload to that takes in our string with the formatting markers in it. And then, actually, let me jump down one.
Yeah.
Actually, the second overload.
The first one, an array.
The first one would take in a single object.
Right.
If we wanted to pass multiple objects, we would have a params-based array. So we could pass in any number of parameters we wanted to and then read them in as individual index-based arguments on the inside.
Now, what I recommend is you go ahead and just get this written into our method right now, and then we can explain that further when we go to put in our functionality.
Right. But just pointing this out, because this is where we're going to get the parameters for WriteLine itself. As WriteLine, you could really see WriteLine as a pass-through to the second overload of string.format.
Sure.
So that means we're going to pass in a string parameter and a params object array parameter. So this will be string.
And once we get to
format.
adding in the functionality, we can actually show you some examples of how this could work. But you've probably seen it all before anyway.
And we'll have params object array, which we will call args.
You know, it's funny. I'm a native Mel scripter. That's how I got started, and I've seen all this stuff before, and I'm used to it. But I still always, there was just at least one little switch in my brain starts to kind of twitch a little bit when I take a method and write it out twice.
Yes, all of the overloading.
Yeah, because Mel would just explode if you tried to do anything that clever.
And the other thing that this kind of parallels is the fact that console.writeLine is also heavily overloaded. There's many different variants. So we're just following that methodology. Though, of course, we have fewer overloads here. We don't really have a direct overload that would take in a number.
Sure.
And an interesting artifact of that is if we want to directly write a number with no string around it, we'll still have to place it in a string.
Yeah.
We'll just place the marker by itself.
Yeah.
But, all right, moving on. We have one final method to address, and that is draw. So we'll have, once again, public static void draw. And draw is simply going to take in a sprite batch to use for drawing. So sprite batch, we'll call the parameter sprite batch as well. And that takes care of our method structure.
Okay, so what I'm going to do is I'm actually going to put Logan on pause here. At this point, we have established our log class, we've put in the necessary public and private fields, and we've built our skeleton of currently empty methods. In the next video, we're going to continue this by adding in full implementations of each one of these methods. Basically give them their functionality.
Exactly.
So we'll start that in the next video. Thanks a lot.